for the presentation.
You're welcome. I mean,
Thank you so much.
Yeah.
For every class attended, they have new information. Now, prior to this, I used to think that ensemble uh, ensemble algorithm is the same thing as hybrid, but I can see here that it's not the same. I just want a little explanation on this.
Okay. Thank you very
Then my
much.
second question,
Okay.
then sorry, can I?
Yeah, go ahead.
So
Go
my
ahead.
second question for this type of what you've shown us on the slide and how to go back and forth through the data preparation, feature engineering, and so on and so forth. It's very interesting, but I think I want to ask, it's easier done on the worker environment than the um, programming environment, like using the MATLAB or Python. So I want more insight on that. Thank you so much.
Okay. Thank you. You're welcome. If I get you right, you want to know if it is easier to do all these things on the weaker side or on the programming side. Am I right?
Yes, yes, yes.
Okay. Thank you very much. The questioner is want to know the little comment about the difference between hybrid and ensemble. Yes, a lot of people do mix these together. They are two different concepts. So sometimes we do ensemble of hybrid. So everything become like the Arab we say mushakel, cocktail. The cocktail. It become cocktail. You keep mixing things together that you can hardly differentiate what have you really missed. Okay? But in a layman, let me make it this way. Sometimes when you have algorithm A, we have an algorithm A, let's say I have a fuzzy logic system, fuzzy logic system, fuzzy logic system. If some data set are there are so many noise in the data. We did something that we use fuzzy logic system, especially type 2 fuzzy logic. We first of all passed the data into type 2 fuzzy logic. So it was able to resolve the fuzziness. The uncertainty in the data was drastically reduced. Now, this output for fuzzy logic system, we now use it to train other machine learning algorithm, like the extreme learning machine, k-nearest neighbor. See, this is called an hybrid. You see, this is called an hybrid model. See, you're starting with something, the result of this is passed to another one. Sometimes we pass the result of this to another one. So this becomes what we call an hybrid model. See, this one sometimes has a function to carry out. The function of it is to treat the uncertainty in the data set. And then the next stage, this one are going to do the final modeling for us, and then we get the result. So that we bring another one in to do some things for us. We have a cascaded, usually hybrid. They are mostly in series. This will finish and go to this. This will finish and go to this. However, in the case of ensemble, this is where you can have system going in parallel. We run like ELM, extreme learning machine, k-nearest neighbor, support vector machine, decision tree. Maybe we have a team of 15 people. Each of you will ask you to go and build like 15 classifiers. And then after 15 times 10 people, that is 150 models. You add one to it to make it odd number so that we can do voting in ensemble type. So we have like 151 model. Each of these model will be given new sample to classify. This one say this is yes. This one say this is no. This one say this is yes. This is no. We now count them. If we are using voting approach, we say what is your vote? 1, 2. Majority carries the vote. We want to take the decision of the final result by considering all these people. Out of 151, maybe 95 model prepare yes as answer. The remaining one say no. We go with the majority, which is yes. Our final answer will be yes. This is called ensemble. And sometimes we have ensemble that is inside another ensemble. This team member one may decide to build an ensemble. This guy also build another ensemble. This one build another ensemble. Then we have the result again to use. Sometimes you have one of the team member is actually building an hybrid model. His own model is not single model, it's an hybrid that has fuzzy logic at the beginning, followed by extreme learning machine. So it means you're having hybrid and you're having hybrid inside ensemble. This is why I say sometimes the whole thing gets clumps together that you can hardly differentiate what this man is doing. But the guideline is ensemble is a way of doing collaborative decision making. Collaborative decision making. Unlike in the case of hybrid, the final model will take the decision. This one here is the one that will take the final decision. These guys are just trying to make the input better. The result of this is also better than what. So finally, we'll be training this guy with a better feature to be able to generate better result. And then when we are going to talk about stacking ensemble, it's a little bit similar to an hybrid. You see, in stacking ensemble, you start with some ensemble like this, and then the outcome is used to train another single model that will generate, we call it meta algorithm, that will produce the result. So that is why some people see the stacking ensemble as more of an hybrid, because it contains a set of ensemble whose output are used to train another model, which form a series. Making it a series becomes making it an hybrid. That's why sometimes you see people say hybrid ensemble. Because when you mix them together, you can have the two on the same system. Hopefully that clarified. The second question is, doing all this, if you have to go back, vision engineering, doing it in Weka or doing it in programming. See, one advantage of programming, I'm a programmer, I love programming, is you can automate what you want to do. Just click something, it does it for you. See? So this is why we can't compare doing something manually with when we automate it in programming. They are not comparable. I can do my programming and run it and go and sleep. Tomorrow I come and get my result already. You get the point now. However, the idea of no coding is to create opportunity for people who are not programming oriented to be able to use this technology, AI. See, otherwise, if we say everybody should go and learn programming, I've seen people started it, they ran away after paying huge money in foreign universities to learn machine learning. They couldn't code because the programming was tough. They couldn't even understand the concept. Because when you are learning a new concept using a language you don't understand, it becomes tougher. So they are programming and using that programming concept to learn machine learning concept. It was tough. So we say, why they need to do that when somebody can actually do AI modeling without writing a single code? So that does not take away the fact that programming is, of course, programming is far better than doing it manually. See, the advantage that is there is when you do it manually on Weka, you pass through the procedure yourself. You go back and change it. You go back and change it. You check. Even the k-nearest neighbor, for example, you check K to be 1. You run the experiment. You record the result. You go back and do it. Change it to 3. You keep doing that manually. Of course, there is an aspect of Weka that supports automation. The experimental aspect of Weka. You see, we can check that out also in our video. Experimental is the experimental section of Weka. You can set it up and just run it and go to sleep also. It's also still visual. You just set it, all the experiment you want to run. I want to check case go to 1. I want to check case go to 3. You do that manually there. You can run it at once and then you can go and sleep. Tomorrow you come and pick your result from your Excel file. That is also better. But once you do it yourself, especially at the beginning, it gives you that particular feeling that you know what you are doing, because sometimes a lot of secrets are hidden in code. See, you don't even know what has been done to the code in a lot of libraries. And you can make simple mistake that is difficult to get. Like recently, one of my students got 100% in his modeling. When you get 100%, that's what we are looking for, but it raised flag. Something may be wrong. 100% is not something you can get easily. In my entire over 20-something years of practicing machine learning and AI, I've only gotten 100% one time. It's not something you get on every day. So I said something must be wrong. I appreciate your work, but please go back and check. After a week, he came back and said, "Oh, Prof, I detected the problem." You see, in programming, if you are not careful, you can program the wrong thing there. That's why people who are not program savvy, they may spend 1 week decoding. Why wasting the time when you can use another platform to get your work done? The good news is no one is interested in how you have done it, either programming, MATLAB, R, Weka. No one cares. What matters is, did you follow due process, the actual process to be done, which is to ensure that you let the data speak. So we cannot compare Weka with programming. Programming is, you know what programming does. It automates something for you. Just click something, start doing it for you. So, and you have to do it manually. Even the experimenter, yeah, it provided for. It is when somebody struggle with programming, and we can't force everybody to program. This is the idea. But if you have programming idea, for example, some of my students, interns, I'd ask them to, they are new to machine learning, they start with Weka. That's that. For 3 months of their training, they're going to be on Weka. After 3 months, they are expected to start graduating to programming in whatever language they like, either Python, R, and whatever. So this is the training perspective. But we can't force everybody to, oh, you must use programming. No, you can do a lot of wonders using the Weka, using K9. There are so many no coding ideas that have been developed, and they are really doing great. So when we actually started this idea of no coding a couple of maybe 5, 6 years, 7 years ago, and because we saw that a lot of people are struggling to learn AI, they abandoned it after halfway. So today it becomes the order of the day. When MIT, Stanford, you see them having program online being advertised on no coding, because that is the reality. Everybody cannot learn programming, and a single bug in programming can take you 2 weeks to debug. It means you are not going to work again until you are able to debug that. So I always ask my students, even when you know programming, always have your Weka or any other no coding platform to work. If this programming gives you too much tough time, quickly solve the problem using this, and then later you can transfer it to your coding. So this is how the two goes together. One is faster, the other one may take you time. So I hope I answer your question. Thank you very much. So I think we have one more question before we call it a day, and that is Prince Adeleye Adedeji. Am I right? I can see
Good
your hand.
morning, sir.
Good
Salam
morning.
alaikum, sir.
Walaikum
And good
salam.
morning to
How are
everyone.
you? How are you?
Fine, thank you, sir.
Family. Thank you.
I know the time is fast spent. I just want to quickly ask this two short questions.
Okay.
On the issue of normalization,
Yeah.
in the machine learning pipeline, when is normalization needed? Because you mentioned that about being careful with using normalized data
Yeah.
for algorithms. And the second one is on the issue of can hyperparameter lead to overfitting, and how can we avoid that? Thank you, sir.
Thank you very much, Prince, for the question. On this, let me answer the second one. We go, okay, let me before I take it as you ask. Regarding the issue of normalization and pipeline, this is an area that needs a lot of rework, and a lot of discussion need to come on board on this, because the mainstream, sometimes we do things, everybody is doing it, even though there are some shortcomings there. Pipeline is a way to automate everything you do. Put missing value treatment, put normalization, put everything inside that pipeline. So everything, once your data arrive, you do everything on it. But the fact remains that sometimes some normalization may give you poorer results. That was what I gave. We have real life examples. That's, you see, it's idea of making things easier, but however, let the data speak principle is challenging some of these concepts. That is good. Pipeline is a good one. It's just like normal water. We have water pipeline. Once you on water from the reservoir, it's go through the pipe until you get your water in your house. The same principle with pipeline when it comes to machine learning modeling. It means once you build your pipeline, just load your new data. It goes through all what you set in, running the experiment automatically until you get your result. But can this guarantee we're going to get better result? This is where we have to ask question now. You see, like I said, I've seen a case where normalization is done automatically on data and they were not getting better result. So when I heard about it, I had to say, okay, can you bring me original data? Try to do it. And then it happens that the original data got better result than they normalize. See, it's not in all cases, but in few cases, you have this scenario. So that is why what is packaged under pipeline is a very popular concept. I know it's going to be very tough to challenge it, but I'm saying let the data speak idea need to be looked critically if we don't want to miss insight into the system. So hopefully we're putting up a book on this concept. Hopefully we are able to get it done so that we can educate ourselves. And hopefully it's going to be a little bit paradigm shift or paradigm cautious. So that sometimes people say, oh, this data is not good because we pass through the pipeline that already has predefined normalization. And when we say normalization, so which normalization method did we even use in the pipeline? You see, there are some of issues. Normalization has several methods. See, I remember one of the time I was dealing with oil and gas data. I have like a 4 or 5 normalization scheme. I comment out using MATLAB then. I'll comment out 3 of them. I use one. I check the result. I comment out another one. I uncheck the other one. I check all the 4 and I check the original data. In several cases, my original data always gave me the best result. So in that case, it means they don't benefit from normalization. A data benefit from normalization if your data has huge disparity. You have age, then you have annual salary in millions, annual budget in billions or trillions. You know, the values are huge. So we normalize each of these trillions to be between 0 and 1, 0 and 1. Your age also should be 0 and 1. This is the idea of normalization. It worked for some problem. But which problem is it not going to work for? We don't know. And that is why we say, let the data speak. How do we let the data speak? Check the result before normalization, check the result after normalization, and go with the one that is working for us. Which means we have to build a pipeline. We have to modify the idea of pipeline. Build a pipeline that has that provision. This pipeline, original data go in and get delivered. The second pipeline, we have chlorine, fluorine already added to the water, and you want the original water. Which one giving us better result? This is what let the data speak idea is generating and is raising. I hope that clarifies, my prince.
I hope that would later be called hybrid pipeline.
That's interesting. Yeah, so this is the idea we're looking at, so that we should not ignore the original data totally. So otherwise, we'll be working with mutilated data that has been tampered with extremely, and then it has its own consequence. And your second question, if I'm not mistaken, can you remind me quickly?
Yeah, can
hyperparameter. Yeah, I got it. Thank you. Can hyperparameter lead to overfitting? No.
And how can we avoid that?
Yeah, hyperparameter cannot lead to overfitting. It's a must to be done. The only thing you have to do is to prevent what we call data leakage. This is the mistake people are having. When they do training and testing, when they are testing, they divide data into 2. Training, testing set. So only the hyperparameter optimization, they use training test to train, and they use the testing set to test, to check the hyperparameter if it's working. If it's not working good, they change the hyperparameter again, they use the testing set to set. This is wrong. Testing set should never be brought into the modeling stage. So the correct procedure is divide your data into 2. The training set should be taken away totally, not used for hyperparameter tuning. You have the training set. That training set now, you can use the 10-fold or 5-fold cross-validation on your training set. This is what you are going to use for hyperparameter optimization. The testing set should never be used for hyperparameter optimization. Otherwise, it means if you do that, you are indirectly letting your hyperparameter know about the testing set. That is compromising your modeling. And this is what we call data leakage. you are linking the testing set to your hyperparameters because they are adjusting themselves until the testing set is good. This is a bad modeling and it's actually wrong. And some of the issue we are addressing in the letting the data speak approach. I hope that clarified the prints.
Thank you very much, Prof. Yes, sir.
Thank you. So I think we, okay, I'll give me there's Ansar Qasim. Can you have a quick question? We already passed our time. I give that opportunity. You can unmute yourself and ask your question. Ansar Qasim, you have the floor. Did you raise your hand or it was a mistake? Ansar Qasim 76 at gmail.com. Maybe it was a mistake. So thank you very much, all. I believe that is how we are going to have it for the day. And thank you for all those questions. So I believe there are very important issues raised. So, and then hopefully it's well clarified. Moving for that, every day we try to see how we can improve upon whatever we are doing. And then we should also try to always put the result of different versions of our work side by side and then see which one gave us the best result. And avoiding data leakage is a must because this can compromise our result extensively. So we think the testing set now is okay, it's working fine, it's getting 99. When they bring the raw data from the industry, then we are not able, the model is not able to get it done because we have allowed data to leak during the development of the model. So once again, thank you very much. I need somebody say I need clarification on hyperparameter. I think I've done that. That hyperparameter is the parameter that is more important that affect the algorithm itself. So we have to get that one right. It affects the performance of algorithm. Other parameters like number of decimal places, should we use randomization factor 1 or 2 or 3? All those has nothing to do with the algorithm. But the K, the number of neighbors, the distance measure, in a support vector machine, the polynomial, the kernel values, the C, regularization factor, these are hyperparameters, which are parameters that seriously affect the performance of our model. So once again, thank you very much all for what we have covered so far. So wish everybody all the best. Hopefully until next week. So hopefully we, by the grace of God, inshallah, we'll be able to meet again and then see how far we can go. Remain blessed. Thank you very much.